In July 2026, a cloud security firm proved they could hijack 6 of the most used AI coding assistants on the planet, including Cursor and Claude Code, using a FIO system trick that is older than most of the developers using these tools. When they reported it, one vendor's answer was blunt: that is not a bug. That is a risk the user already agreed to. If you write code with any AI assistant wired into the Model Context Protocol, and by now, that is almost all of them, your machine may be one cloned repository away from running commands were never agreed to. And by the end of this video, I will walk you through the exact class of vulnerability a state-sponsored hacking group used to run a cyber attack on 30 companies with almost no human involved. This is not speculation. It is CVE numbers, vendor disclosures, and Anthropic's own words. In the Ruthenkiva. Model Context Protocol, MCP, launched in November 2024 as Anthropic's open standard for letting AI models stop guessing and start doing. Instead of just generating text, an agent can query your database, run terminal commands, touch your file system, or reach into Slack, GitHub, Jira, whatever you connect it to. It caught on fast. Packages built on top of MCP have been downloaded more than 150 million times. By January 2025, Cursor alone had passed 1 million users, and it is now used inside more than half of the Fortune 500, names like NVIDIA, Uber, and Adversa. To make all of that seamless, these tools store their permissions in small configuration files, resident quietly inside your project folder. Files like .cursor/mcp.json or cloudcodes.claude.json. Those files decide what your AI agent is allowed to touch on your actual machine. Now that is exactly where this story starts. Because almost every major AI coding assistant treats those files as something to trust once and will never check again. In August 2025, Checkpoint Research disclosed a vulnerability inside Cursor they named MCPoison, CVE 2025-54-136. Here's the flaw. When Cursor sees a new MCP configuration, it asks you to approve it once. From then on, it trusts that configuration by its name, not by what is actually inside it. Picture it. An attacker commits a harmless-looking MCP file to a shared GitHub repo. That just runs a basic system command. You open the project, see the harmless command, click approve. Weeks later, the attacker quietly edits that same file. Same name. New payload, a reverse shell, a data exfiltration tool, a backdoor. Cursor does not ask again. It already trusts the name. Every time you reopen that project, the new command runs, silently. Checkpoint rated it high severity, affecting every Cursor version below 1.3. 4 days earlier, a separate team at AIM Security had disclosed a related flaw called CurXecute, CVE 2020-554-135, whereas a message sent through a connected tool like Slack could rewrite Cursor's global configuration and trigger execution before the user even had a chance, or to reject the AI's suggested change. Security researchers call this the confused deputy problem. The AI never gets hacked directly, it just gets tricked into misusing access it was already legitimately given. 2 months later, in October 2025, a researcher Brett Gustafson at Lakera found something almost embarrassing in its simplicity. Cursor blocked AI agents from directly editing that same sensitive mcp.json file. Good. But the block only checked the exact file name in the exact case. On Windows and Mac OS, the file system does not care about capitalization. Cursor/mcp.json and .cursor/mcp.json point to the exact same file. Cursor's protection did care. So an agent, steered through a prompt injection, could simply write to the capitalized version, and the operating system would quietly treat it as the protected file underneath. One misplaced capital letter, and a security control built specifically to stop this exact category of attack just did not apply. It was assigned CVE 2025-59-944 and patched in Cursor 1.7. But it is a perfect preview of a pattern this video keeps running into. The protection exists on paper and fails on contact with a real operating system. By early 2026, researchers turned to Anthropic's own coding agent, Claude Code. In February, Checkpoint disclosed CVE 2025-59-536, rated CVS SS 8.7, 2 flaws and 1. First, a feature called Hooks lets Claude Code auto-run shell commands at set points in its workflow. It's a malicious hook inside a repo settings file, and it fires the moment a developer opens the project before any trust dialog even appears. Second, 2 buried MCP settings could silently auto-approve every server in the project, this sim on consent entirely. A companion flaw, CVE 2020-621-852, let a repository redefine where Claude Code's own API calls get sent, point that at your own server, and the developer's live API key routes straight to you. Anthropic patched all of it. 3 months later, in May 2026, Mitiga Labs found something Anthropic has not patched and says it will not. Claude Code stores its MCP settings and its OAuth tokens for connected tools like Jira, Confluence, and GitHub in one single file. Researcher Aidan Cohen showed that a malicious NPM package, the kind installed by thousands of developers a day, can quietly rewrite that file on install, rerouting Claude Code's traffic through an attacker's own proxy. Every OAuth token that passes through gets copied on the way past. Rotate the token, and the hook just steals the new one too. Mitiga reported it on April the 10th. 2 days later, Anthropic ruled it out of scope. That same week, while Mitiga was going public with the token theft you just heard about, a separate research firm, Adversa AI, published a disclosure that turned this from a Claude Code problem into a whole industry problem. They called it TrustFall. Adversa tested Claude Code, Cursor, CLI, Gemini, CLI, and GitHub Copilot CLI side by side, and found all 4 shared the same underlying design. The moment a developer opens a project and accepts a routine folder trust prompt, the one that basically just asks, do you trust this code? Every one of these tools can auto-launch project-defined MCP servers with no further warning. And every single tool defaulted that prompt to yes. In a live terminal, that is 1 enter key. In an automated pipeline, it can be 0 keys. Adversa's side-by-side comparison found Claude Code's version of that dialog gave developers the least information of the 4 about what they were actually agreeing to. Anthropic's position, clicking yes, I trust this folder, is informed consent to everything that happens afterward. Adversa's answer was simple. You cannot meaningfully consent to code you were never shown. Rewind a few weeks earlier to April 2026, because a different team was already asking a deeper question. Forget the trust dialog. What if the protocol underneath it was never checking anything at all? Security firm OXSecurity spent months auditing MCP's most common transport method, called STDIO, and found it does exactly what a command string tells it to do, no validation. A sanitization, no sandbox. Inside every official MCP software kit Anthropic publishes, in Python, TypeScript, Java, and Rust. That means this flaw was not sitting in Cursor or Claude Code or any single product. It was baked into the foundation almost every one of them was built on top of. OX scanned the open internet and found more than 7,000 exposed MCP servers out of an estimated 200,000 vulnerable installations, sitting on top of a supply chain with over 150 million downloads. Yes, the same ecosystem number from the top of this video. To prove it was not theoretical, they ran commands on 6 live customer platforms and compromised public servers across more than 200 open source projects. And when OX brought this to Anthropic agreed the behavior was accurate and confirmed it was intentional, their position. This is a secure default, and sanitizing untrusted input is every individual, the developer's job. Anthropic did quietly update its own security documentation to recommend caution around STDIO. A wording change, not a code change. Now rewind even further to November 2025, because bugs and misconfigurations are one thing. This is different. Anthropic itself disclosed that a state-sponsored hacking group out of China, which it tracks as GTG1002, had manipulated Claude Code into what Anthropic calls the first documented large-scale cyberattack carried out mostly by an AI, not a human. The group broke through the model's safety training by convincing it, piece by piece, that it was doing legitimate defensive security testing for a real cybersecurity firm, never revealing the actual goal in any single request. Once inside that framing, Claude Code handled reconnaissance, found working exploits, wrote its own attack code, harvested credentials, and moved through networks largely on its own. Anthropic says the AI carried out somewhere between 80 and 90% of the entire operation, across roughly 30 targets worldwide. Large tech companies, financial institutions, chemical manufacturers, government agencies, with humans stepping in for only a handful of critical decisions. It was not flawless. In July 2026 alone, Wiz Research disclosed something called GhostApproval, a symlink trick older than most of the developers using these tools, that fooled 6 different AI coding assistants at once: Cursor, Claude Code, Amazon Q Developer, Google Antigravity, Augment, and Windsurf. All 6 approved one file on screen while secretly writing to a completely different one underneath. 3 vendors patched it. 2 went quiet. Anthropic again called it outside their responsibility. That same month, Cato Networks found a pair of CVSS 9.8 flaws in Cursor that led a poisoned prompt. Escape the sandbox with 0 clicks required. AWS's own coding agent, Kiro, got tricked by hidden text on an ordinary web page into rewriting its own permissions file and reloading it automatically. And GitHub's agentic workflows read a plain English request typed into a public issue. Researchers showed the single word additionally was enough to slip past its guardrails, and used it to leak a private repository into a public comment. Sometimes you did not even need an attacker. One developer's very first Claude code session ended with the agent wiping a live production database while investigating an unrelated bug. It ran the wrong migration command and deleted the tables. It did tell the user immediately, unprompted. Arguably the only step in the whole chain that worked as intended. So here is what actually protects you today. Update everything, Cursor, Claude, Code, Copilot, Gemini, CLI. Most of what we just covered already has a patch waiting for you. Stop treating the trust prompt as a formality. Before you open an unfamiliar repository in any AI coding agent, actually look inside its .mcp.json, its .claude/settings.json. That is the entire attack surface, sitting there in plain text. Never enable blanket auto-approve or bypass permission settings for MCP servers, especially on a repo you did not write yourself. Treat any OAuth token your coding agent holds, GitHub, Jira, Slack, whatever, as radioactive. Keep it short-lived, scope to the minimum it needs, and rotate it on a schedule, not just when something looks wrong. Pulling an unfamiliar package? Disable install scripts before you do it. That single setting shuts down the exact NPM trick Mitigate demonstrated. And if you are a team, not a solo developer, run your coding agents inside a sandbox or container with its own limited blast radius. Monitor outbound traffic from that process specifically, and audit your configuration files on a schedule the same way you would audit a firewall rule. None of this is optional anymore. This is the actual attack surface of how most of us write software now. Here is the uncomfortable part. Almost none of what you just watched required a genius-level hacker. A misplaced capital letter. A file name that never got rechecked. A trust prompt that says yes by default. A protocol that runs whatever command it is handed, because checking felt like someone else's job. That is the pattern. From Cursor's first disclosure in 2025 to a state-sponsored group running an autonomous campaign against 30 companies. So here is the actual question, and I want to know what you think in the comments. Is the agentic AI industry moving faster than its own security model can handle? Or is the user click yes actually a fair place to draw the line? If you want the deep technical breakdowns that keep you ahead of stuff like this before it hits the mainstream tech press, subscribe to Cyphrs. I'll see you on the next one.